changes quite spontaneously, and it was quite a surprise when I first discovered this, but it explained a lot as to how nature is creating these boundary conditions. And here we can see an example of what that same pattern would look like as a torus in this cone flower here. Now, to understand the phi scaling angle, I just want to provide a brief introduction to the Fibonacci numbers and the phi ratio, which probably most everybody here is already familiar with, but in case anybody isn't, here's a simple introduction. The Fibonacci sequence is a series of numbers derived by starting with the numbers 0 and 1, adding them together to get 1. Then you take the first one and the second one together to get 2, and add 1 and 2 to get 3, and 2 and 3 to get 5, and 3 and 5 to get 8, etc. You get this sequence of numbers called the Fibonacci sequence. And now, these are related to the phi ratio because when each pair of numbers is divided, the farther out the sequence you go, the closer the result gets to the mathematical phi ratio. So nature is actually using the quantized Fibonacci numbers to approximate the phi ratio. The phi ratio, of course, is a ratio of 1 to 1.618. And that's what nature, through the quantization and the harmonics of the phi Fibonacci numbers, is actually coordinating space and time with this ratio. And this brings us to the phi scaling angle, which is 27.3 degrees. And it's derived quite simply by taking a series of circles or spheres, each one in a Fibonacci number diameter of growth. And you can see it creates this green angle here, which I call the phi scaling angle, 27.3 degrees. And I became very fascinated by this angle a long time ago and began to see its presence in nature quite a bit, which I'll show you in just a moment. But I also want to show you a very key aspect of the role this angle plays in very fundamental universal energy dynamics. And to do so, I want to build up a blueprint, a phi blueprint, and show you how it gets derived. It begins with a series of little units, little squares, each growing with Fibonacci numbers of units with 90-degree turns to create this little matrix here. We could add squares to define each one of those. And when we do, we get what are called golden rectangles, where one edge is the unit of 1 and the other edge is 1.618. And the whole matrix of these squares becomes a matrix of golden rectangles that are fractally embedded. Within each square, we can then add a quarter circle arc. That's the same radius as the edge length of the square. And that creates a very close approximation to a phi spiral. It's the quantized phi spiral, not the mathematically derived one. But nature is using the quantized phi spiral. And to this, we can add what I call nodal points, these little red points that show each iteration of the phi ratio across the spiral here. And this is important because here now I've just zoomed back out to where I'm seeing a larger portion of the spiral. We were just looking at this quadrant up here. Now we're seeing a bigger part of the spiral, which can go on into infinity. And connecting all these nodes creates what I call this nodal axis that is fundamental to the geometry that's creating this phi ratio, this phi spiral. And then continuing on in the process, we now take the original spiral and duplicate it, spin it to create a phi vortex. And this is what we see in nature. We see mostly vortexes and double spirals rather than just the single spiral. So it's important to be able to map it as a vortex. And you can see actually right here that that boundary condition I mentioned earlier actually appeared when we did that. And that's what happens every time you spin these phi spirals. And now in the universe, we have two spiraling directions. We have this counterclockwise spiral that's going in towards the center in a counterclockwise manner. And we have the same thing happening in the opposite direction, a clockwise spiral. And this is called chirality. That's the spin of systems within the universe. And there's actually an offset angle between the two. So if I go back to this first one, you can see the nodal axis coming down this way here. And the next one, the nodal axis is coming down this way. So there's actually a differential between the two geometries that create this phi ratio spin. It turns out that this differential chirality offset angle is exactly the phi scaling angle, which I didn't realize for many years until it suddenly dawned on me. I looked at it and I said, that looks about the same. And it turns out it's exactly the same. So this phi scaling angle is really fundamental to how energy dynamics are organizing in the spiraling directions of systems within the universe. Phi scaling angle, there it is. And so within this one blueprint now, we have the Fibonacci units, the little squares. We have the golden rectangles. We have the phi spirals themselves. Then we have the phi double spiral field pattern. We have the phi proportions of the circles. And we have the phi scaling angle. And actually, when we zoom in to the center, we once again highlight that we also have the phi boundary condition. So this is really, for me, kind of a master blueprint of how the phi ratio is organizing in the universe. And I want to show you some examples of this phi double spiral pattern before we get to the phi scaling angle in nature. And again, we're looking at this fundamental double spiral pattern as the cross-section of a torus that is really the most fundamental coherent organizing form of energy dynamics. And we can see that here in Mammillaria cactus that creates a beautiful double spiral with this toroidal round shape. You see the same thing with the pine cone, and the spirals in one direction and in the other direction are both Fibonacci number quantities. We see the same thing with the pineapple, both in the fruit of the body and in the leaves, you can see. So this vortex of energy is creating this form. Here we see it in the branch of a spruce tree, and we can see where the needles used to be on the branch now show us that there's the same double spiral pattern going on every branch, every twig of that spruce tree. The same pattern is being followed. Here is the same tree, literally the same tree. I took this picture 2 different times of year, showing the spruce cone double spiral pattern. Now here we see a red smoke flare, and an airplane has just taken off right by that flare, and the spiral off the wingtip is creating this phi vortex. And you can see I put the boundary condition here to show how that whole thing is really clearly coordinating in that phi ratio relationship. We can see the same thing here with this Hurricane Katrina, beautiful phi spiral, and the eye would be where the boundary condition is defining that space, the inside and the outside of the system. Now we go up to this huge scale, 90 light years across, at this galactic scale to see exactly the same pattern. You see now the fractal nature and the toroidal phi ratio embedded aspect of universal energy dynamics. And here's one of my favorites. I just find this so fascinating, taking that boundary condition and putting it over the iris of the eye and looking at the double spiral field pattern. You can see how beautiful the contours are of the nose and of the eyebrow and of the eyelids here, how well it's coordinated with this field pattern. There's a whole area of study yet to really be done in this dynamic, but it certainly visibly shows us that there's something correlated clearly to how this pattern is organizing. And I find this fascinating how our eyes, our consciousness, our perception on the world, our bodies are all made of this universal field expressing and coordinating in this beautiful harmonious way, all as one. So that brings us now to the main topic of what I wanted to show you and how it was derived is the phi basket weave and the phi scaling angle. And it begins by looking at trees. And trees, of course, are torus dynamic systems. In fact, we can see them as a double torus system with the tree canopy at the top and the roots down below in the earth, exchange